Welcome to lab number 5. Today's experimental topic is convection and radiation heat transfer from a cylinder. The equipments used in today's experiment are our arm feel HT14 along with our arm feel 10XC computer control box and a computer. The HT14 is a stainless steel cylinder that sits on top of a centrifugal fan at the base of the apparatus that pushes air through the duct. The speed of the air flow can be varied by a throttle plate. This is done so by screwing the throttle plate in to allow more flow and in to decrease the flow. Next, there's a thermocouple notated as T9 fitted to the wall of the duct to measure the upstream air temperature. Now, down from T9 or up from T9, we have the anemometer that provides reading of air velocity directly in the units of meters per second. At the very top of the apparatus, of the vertical cylinder duct, we have a horizontal cylinder. Now the heated portion of the cylinder, which is inside, is 10 millimeters in diameter and 70 millimeters long across the duct. Connected to the surface of the cylinder is thermocouple T10, which allows us to read the surface temperature at the heater. Also, I'd like to point out that the cylinder is coated with heat-resistant paint, which provides consistent emissivity close to unity. Now, all these instruments on the HT14 are connected to our HT10XC. This allows us to control the power supply of the heater and also to take direct temperature readings throughout the duct, both up and downstream. Now finally, our 10XC is connected to our computer via our USB cable. This allows us to use the ArmField software to collect data. Now let's start the experiment. So we would go to our ArmField folder and we go to our 10XC unit, and the equipment we're using is the HT14 and we're using exercise B. So now we're in the ArmField software, and as you can see, it's indicating our duct temperature, and then it's giving our air velocity, and then at the top we have the heater temperature. And on this side we can control our voltage and our current. Now let me point out, in today's exercise we will not be using the centrifugal fan. It's going to be a free convection, and we're going to be doing 5 different conditions. So we're going to be taking readings at 5 volts, 8 volts, 12 volts, 15 volts, and 20 volts. So at this point we would turn the system on and we would bring our voltage up to 5 volts. Now, after setting the heater voltage to 5, would allow sufficient time to achieve a steady state condition. After the temperature has reached some form of equilibrium, we would take readings of T9, T10, voltage, and current. Now, we would simply scroll over to go when we have reached equilibrium, and would go to our tables and you'd see our readings. The difference with this exercise from the previous ones we've did, when we get back to our diagram, we are not allowed to read again. We would have to go to next. And what next does is to create another Excel window. So let me go back to table and show you. So at the bottom here, you'd see, and would label this one 5 volts and say OK, and would label this one, next would be 8 volts and OK, and then we would go back to our diagram. And what we'll do next now is to adjust our voltage to 8 volts. So we would go up to 8 volts. And we would repeat the process. As soon as we have allowed sufficient time to achieve a steady state condition and or we have reached some form of equilibrium, we would scroll over to go back to our tables, and you'd see would have readings for 8 volts. What we would do is continue to do the same process of creating another file next. And we would name this one 12 volts. Then we would go back to our diagram, increase our voltage to 12, allow again for a steady state, and would go ahead and take readings, go back to our table, and now we've got 5 volts, 8 volts, and 12 volts. So we would continue the same process by changing this one, adding 15 volts. Okay, so now we have 15 volts. We go back to our diagram, up our voltage to 15, and of course allow for a steady state, take readings, verify the data has been collected. It has. Then we would go to next, and finally add for 20 volts. Then we go back to our diagram, adjust the power to 20 volts, and allow for a stable condition, allow for equilibrium. Then we would take readings again. So now we can toggle at the bottom between our first reading 5 volts, 8 volts, 12 volts, 15 volts, and 20 volts. And their tab at the bottom here, as you can see, 20, 15, 12, 8, and 5. And that would complete today's experiment. And we used our HT14, and we have our T12 2 at the bottom, we have our anemometer to take velocity readings, and we have our T10. I'm sorry, this should be T9 and T10 at the top. So at this point, the experiment is complete. Any questions, feel free to contact your professor, Dr. Whitworth. Thank you.